Hello, today we're going to do notes on ions and solubility. So, we've learned about ionic compounds. Many ionic compounds will dissolve in water. So let's get a little bit better understanding of what that means. If something will dissociate, that means that the ions will separate in water. Alright, so an example, if you have sodium chloride, that's a solid, and you add it to water, the sodium ions will pull apart from the chloride ions. And they do that because the water molecules surround them and pull them apart. Water molecules are what we say polar. Oxygen and hydrogen share unequally. Oxygen has a much higher electronegativity, so it pulls on the electrons and they spend most of the time going around the oxygen. That gives the oxygen end a negative partial charge and the hydrogen end a positive partial charge. So what happens is they will surround those salt and chlorine, or the sodium and chlorine ions, and pull them apart into solution. And that's what dissociation is. It's the same as dissolving, only when things dissolve, they don't get pulled apart. And when they dissociate, they do. Aqueous simply means something is dissolved or dissociated. Something that is soluble has the ability to be dissolved. Something that's insoluble will precipitate when it's put in water. And then an ion, of course, is an atom with a charge. An electrolyte is basically an ionic compound. An electrolyte is a substance that allows electrical current to pass through a solution. Now this next question says, which one of the following compounds would ionize in water? And we're going to change this question to what ions are formed from each one of these compounds. Iron 2 hydroxide will dissociate into iron 2 ions and hydroxide ions, and there's 2 of them, so we have to have a 2 there. Potassium chromate will dissociate into potassium ions and chromate polyatomic ions. Cobalt 2 nitrate will dissociate into, oops, I did that wrong. Cobalt with a +2 charge and 2 nitrate ions. Potassium iodide will dissociate into potassium ions and iodate ions. Magnesium phosphate will dissociate into magnesium ions and phosphate ions. Ammonium hydroxide will dissociate into ammonium ions and hydroxide ions. Nickel 2 sulfate will dissociate into nickel 2 ions and sulfate ions. Potassium permanganate, I need more space, will dissociate into potassium ions and permanganate ions. My face is behind there, or in front of these, so I'm going to move that. Zinc hydroxide will dissociate into zinc ions and hydroxide ions. Lead chloride will dissociate into lead chloride ions. And then nickel triiodide, I don't even know why it's on this page because it has nothing to do with this. All right. First of all, I've got to erase the text. And now we're going to add another page in. And here it is. So, it says draw a picture of what it would look like for the compound to split into its ions. So we need to have water molecules in here to begin with. I'm going to use red for my water molecules. And water molecules, of course, have a hydrogen, 2 hydrogens, and an oxygen. They look like Mickey Mouse, which is why I like to wear the Mickey Mouse ears when I talk about water molecules. And what happens is that, just like I showed you on the page before, those ions have a slight partial charge. The oxygen end has a slight negative charge, and the hydrogen end has a slight positive charge. So when you put something that will dissociate in water into the water molecules essentially pull it apart if they're strong enough. Not all things will dissolve easily in water, as we will soon see. All right, lead nitrate's going to dissociate into lead ions and 2 nitrate ions. So if we put this in here, the lead would be attracted to the negative end of the water molecule, and the nitrates would be attracted to the positive end. All right, and there I've dissociated it. Calcium 2 chloride, same story. We would have calcium ions and then 2 chlorine ions for each one calcium. So again, calcium is going to be on the water end, and the chlorides will be on the hydrogen end. Sodium 2 sulfate. This time we're going to have 2 sodiums for every 1 sulfate. Oops, I don't know why I did that. So I need 2 more sodiums. And then lithium fluoride, we would have lithium on the negative end and the fluoride attached to the, or attracted, not attached, to the positive end. All right. Ionic equation notes. Some ionic compounds break into ions when they are dissolved in water. You can determine whether or not they will break into ions based on their solubility. If the compounds break apart in water, you can represent them as positive and negatively charged ions. Factors that affect solubility include the charge of the ions, the temperature of the solution, the type of substance, whether it's ionic or covalent, if it forms ions or not, and the polarity, which means is it attracted to the water that has a positive slight positive charge and a slight negative charge. All right. All right, we never want to split up covalent, I'm going to take this or out, molecules into ions. Okay? Only ionic solids will split up into ions in water, and you must check the solubility table to find out whether they will ionize. All ionic compounds will ionize to a certain degree. Ionic compounds consist of metals and nonmetals. If you wanted to, you could also have cations and anions. Which of the following substances would split into ions in water? Well, carbon dioxide is covalent, so that's not one. Sodium chloride, yes. Water molecules, ironically enough, will ionize a tiny bit. So we're going to go ahead and circle them. They're kind of ironic. I wouldn't have included them in this. Sulfur hexafluoride will not. Lead nitrate definitely will. Sucrose, table sugar, will not ionize, although it will dissolve. Silver will ionize in water, and sodium sulfate will ionize in water. All right, our last little bit here. Which of the following substances would split into ions in water in the following equations? Okay, methane, covalent, not going to happen. Oxygen, not going to happen. Carbon dioxide, no. The water won't. Zinc, of course, it's a compound. It's an element. But silver nitrate will ionize, and zinc nitrate will ionize. No silver. Sodium hydroxide will ionize. Copper 2 chloride will ionize. Sodium chloride will ionize. Copper 2 hydroxide will form a solid. So that's what we're going to talk about next, is how to read the solubility table and determine what is going to precipitate. Thank you very much.